Good afternoon to everybody. In last lecture, we have seen the concept of binary search. So, in binary search, the elements of array should be in ascending order. In previous lecture, we have seen the program on binary search. Now, we should have to write the binary search algorithm with iterative method. So first, we write command. So given an array A, given an array A, the number of elements 1 to n in non-decreasing order, and n is greater than equal to 0, determine whether x is present, determine whether x is present, and if so, and if so, return j, such that x is equal to a of j, else return 0. Okay, the array size is n in non-decreasing order. Elements are present in the array and n is greater than equal to 0, and we should have determined x or particular element is present in the given array or not. If it is present at jth location such that x is equal to a of j, then return j, otherwise return 0. If it is not present, then return 0. So for ascending or for binary search, there are required 3 elements or 3 variables. Low is equal to 1, because in this array we start elements from 1. Then high is equal to n, last element. Then here we should have to check and first find mid. Mid is equal to floor, low plus high floor complete divided by 2. What is meaning of this operator? This operator meaning is floor. Suppose you have written one floor 1 by 1.2, which is equal to 1. Then suppose floor 1.8, which is equal to also 1. It gives previous pure number. or previous integer. Suppose minus 1.2, then it gives minus 2. Meaning of this floor. Then first we have declared low is equal to 1, high is equal to n. Then first find mid, floor, low plus high, all divided by 2. Then first we should have to check while low is less than equal to high. Then do, then do, then first check if a of mid is equal to x, then write x is present. Else if x is less than a of mid, x is less than a of mid, then here high is equal to mid minus 1. Else low is equal to mid plus 1. Then return mid, or again find mid. Mid is equal to floor, low plus high, all divided by 2. Then return mid, then bracket complete. Else return 0. Then main bracket complete. This is the iterative binary search algorithm. See this algorithm carefully. While writing algorithm, first we have written comment. In comment, that is given array A with size n, that is there are n number of elements in non-decreasing order, and n is greater than equal to 0. And we should have to determine whether the particular element x is present in that array or not. If it is a present, then return the j element j such that x is equal to a of j. If it is not present, then return 0. For these, we require to declare low is equal to 1, high is equal to n. Then first find mid. Okay. Then condition is low is less than equal to high. If this condition is true, then do if a of mid is equal to x, then write x is present. Else, if x is less than a of mid, then high is equal to mid minus 1. Else, low is equal to mid plus 1. Then again find new mid, then return that mid. If the low is less than equal to high, this condition becomes false, then return 0. This return 0 indicates that there is no particular element present. Did you get? तुम्हाला हा अल्गोरिदम समजलेला आहे का? याच्यानंतर हाच अल्गोरिदम आपल्याला रिकर्सिव्ह अल्गोरिदमचा वापर करून लिहायचा आहे. समजला नसेल तर नाही म्हणून सांगा. रोल नंबर 820. A44, are you there? B12. B31. B63. Did you get this algorithm? Okay. Before going to recursive algorithm for binary search, we should know the concept of divide and conquer. The concept of divide and conquer, that is algorithm divide and conquer. If p small p, that is a problem. If p is small or problem is small, then return solution of that problem. Okay, find the solution of that problem. Else, divide the problem p into sub problems p1, p2 up to pk. Then apply divide and conquer algorithm on P1, divide and conquer algorithm of P2, divide and conquer algorithm of P3, divide and conquer algorithm PK, then combine, that is return combined solution of combined solution of P1, solution of P2 up to solution of Pk, so that we get final solution of problem P. So same concept we are going to apply in binary search algorithm with recursive algorithm. See this algorithm carefully. Next, we are going to see the recursive algorithm in binary search. So first we will write name of the algorithm and its parameters. Algorithm binary search and parameters A array I L X. So comments given array A of I to L. Here I is the starting element and L is the last element of non-decreasing element such that I such that 1 is less than equal to I is less than equal to L, and determine element X is present and if so, return J such that X is equal to A of J, else return 0. So there are two cases. First case, suppose this array contains only one element, suppose 10, and I want to search X is equal to 10. Then how many comparisons? In this case, the problem is small. We can find direct solutions. So first if L is equal to I, that is only one element is present, then return I. See the first case here. In the given array, I is the starting element and L is the last element. There are number of elements in non-decreasing order such that 1 is less than equal to I is less than equal to L, and we should have to determine whether X is present in given array or not. If it is a present, then return a J such that X is equal to A of J. If it is not present, then return a 0. So first, by applying divide and conquer algorithm, if the problem is a small, then find the solution. Similarly, if here array is very small that contains only one element, that is L is equal to I, then return I. L, that is it contains more than one element, then reduce, that is reduce the P into sub problems. Reduce the array into sub array. So for reducing into sub array, here we should have to find mid. So mid is equal to floor I plus L, and floor complete divided by 2. Then compare if X is equal to A of mid, then return mid, then return mid. Else, if this condition is not true, then else, then again check if X is less than A of mid, then return binary search A I mid minus 1 X. Else return binary search A mid plus 1 L X, then bracket complete. See this algorithm carefully. I okay. First, they have given array with elements I, L. I is the starting element and L is the last element, and this number of elements in non-decreasing order, such that 1 is less than equal to I is less than equal to L, and we should have to determine a particular element X which is present in given array or not. If it is present, then return J such that X is equal to A of J. If it is not present, then we should have to return 0. So by using divide and conquer algorithm, there are two conditions. First, we should have to check what is the length of that algorithm. If there is only one element is present in that array, then L is equal to I. That is only one element is present, then L is equal to I, then return I. If there are more than one element, then reduce the array into sub array. And for this procedure, we should have to find the mid of given array. So for finding mid of array, in previous algorithm, we have used a low and high. Instead of this, here low is equal to I and high is equal to L. See, because see in this condition, 1 is less than equal to I is less than equal to L. And as I discussed with you, I is the starting element and L is the last element. And so we can find low is equal to mid is equal to low plus high divided by 2. If X is equal to A of mid, if X is equal to A of mid, if this condition is true, then return a J, that is return a mid. If this condition is false, that is X is less than A of mid, then return here we have used the name of the algorithm and its parameters. That is, we are calling the same algorithm once again. See here, name of the algorithm is binary search, and there are 4 parameters. That is A array, I is the starting point, starting element, L is the last element, and X the element to be searched. So in return, we have written as name of that algorithm, then array A as it is, I as it is. Instead of L, we have written as mid minus 1. Now value of L or last point. Suppose here this is the array 10, 20, 30, 40, 50, 60, okay, and this array contains these 6 elements. I is the starting element, L is the last element, and mid is this element. Mid is this element. So, and I want to search, suppose 10. I want to search 10. So again, array A, then starting point I as it is, then mid minus 1. Now L is here, mid minus 1. Now L is here, and search key as it is. Now this array, previous array is divided into sub array. This is left side sub array. Suppose instead of 10, I want to search 60, then go to the next part, else return binary search A as it is, the sub array. Then instead of I, here mid plus 1. So now I is here, and this is the sub array element L as it is, and X to be searched. Again, go here. Suppose I want to search 10, X is equal to 10. Then I and L, there are only 2 elements. Then here L is equal to I. This condition becomes false. Then again find the mid of that array, sub array, and mid of that I is equal to I. Okay. Then check X is equal to A of mid, and value of mid is equal to I. So X is equal to A of I. If it is true, then return mid. Okay. Suppose next case, I want to search 60, then sub array as it is. Then instead of I, mid plus 1, then L as it is, X to be searched. Then first I will check L is equal to I. No. Then find the mid, and mid of these is 50. Mid of this sub array, this is the sub array, mid of this sub array is 50. Then I will check again X is equal to A of mid. No. Then I will again check X is less than A of mid. No. Then again I will go here. Binary search is equal to, again, this is your new array. This is your new array. Mid is A as it is, new array. Then I is equal to mid plus 1, that is value of I. Then L as it is, value of L, and X to be searched. Then I will check here if L is equal to I. Yes, L is equal to I, because only one element, then return I, that is return 60, and this is element. This shows that the element is present in that array. Did you get? समजलेलं आहे का?
Yes, sir.
Okay, this is the algorithm with recursive search algorithm with recursive algorithm. In recursive algorithm, we can call same algorithm with parameters as it is in same algorithm. Okay. Then this concept over here. Next concept, that is, suppose you have given array A, array A is given, and these are the elements in that array. Okay, and I want to search maximum and minimum or greatest number, maximum number or max number and minimum number. You can simply write, you have given array, you can simply write a C language program on these. Next concept is finding maximum and minimum from given array. So as you can see, this array is a very small, and your maximum number is 9 and minimum number is 1. So we should have to find what is the maximum number and what is the minimum number if the array should be sorted or maybe sorted or not sorted. Depends on user's choice. Then you should have to write a program for finding maximum and minimum of given array. So we are trying to write program on this, finding maximum and minimum. So here we are writing a program for finding maximum and minimum int. Suppose array size is 100, then variable I, then n, then max, then min, then printf slash n, enter size of array, scanf percentage d, and n, here n variable taken for size of array, then printf array elements, for I equal to 0, I less than n, I plus plus, scanf percentage d, and a of I, okay. The elements are entered to this keyboard. I want to display this array element. So for displaying, the array elements are for I equal to 0, I less than n, I plus plus, then percentage d and a of I. Okay. Now here you should declare max is equal to min is equal to a of 0. Max is equal to min is equal to a of 0. Here declared a max is equal to min is equal to a of 0. Then for I equal to 0, I less than n, I plus plus, if min is greater than a of I. if mean is greater than a of I, if this condition is true, then mean is equal to a of I. If max is less than a of I, then max is equal to a of I. Then printf slash n mean is equal to percentage d max slash n max is equal to percentage d then mean and max. Then return 0, then bracket complete. Okay, this is the code. See the code carefully. First, we have declared the array size 100 and taken 4 variables: I for loop, n for size of array, then max and mean. So first we have entered size of array. Okay, with that size we have entered the elements. Then this code indicates the elements. Enter the elements, display. Then we have declared a max is equal to mean is equal to a of 0. Then for I equal to 0, I less than n, I plus plus. If mean is greater than a of I, then mean is equal to a of I. And if max is less than a of I, then max is equal to a of I. Then printf the particular values of mean and max. We will execute this code. Enter size of array. Suppose size of array is 5. Enter array elements 5, 3, 1, 4, 5, 3, 1, 4, 2, 3. The array elements are and mean and max. See the code and output carefully. We'll take 1 minute pause. Is there any doubt in this program? Is there any doubt? Did you get? तुम्हाला समजला प्रोग्राम हा? रोल नंबर 822. A45, B20, B50. Are you there? Did you get? Okay. Now we are going to write algorithm for the program. That is right. There is no use of any recursive function, any recursive algorithm, or any recursive part. Okay, we can directly write the algorithm for this program. So here, name of the first algorithm, create max mean, and parameters are a array, n number of elements, then max for finding maximum element or greatest element, and min for finding smaller element. Okay, then comment set max to maximum and min to minimum of array a 1 to n. Okay, of array 1 to n. Okay, you have given n number of elements in the array. You can directly set max is equal to min is equal to a of 1, because here 0th element is 1, so a of 1, and then for I equal to 2 to n, for I equal to 2 to 2 of is greater than max. If a of I is greater than max, or you can write max is less than a of I, then max is equal to A of I. If mean is greater than A of I, then is equal to A of I. Then bracket complete. This is the state or simple algorithm for finding maximum and minimum of the given array. See this algorithm carefully. If you have any doubt, please ask. There is no doubt. Now we are going to see the recursive algorithm in this program. Now in this algorithm, before that, tell me what is the best, worst, and average complexity of this algorithm of this program. Best complexity, average complexity, and worst complexity for all these three: best complexity, average complexity, and worst complexity is a 2 in bracket n minus 1. This is the best complexity, average complexity, and worst case complexity for this algorithm or this program. Okay. Now we are going to see the same finding maximum minimum algorithm with recursive algorithm. So before that, before applying this recursive algorithm or before writing this recursive algorithm, suppose we will consider there is only one element in the given array. Then answer is max is equal to 10 and min also is equal to 10. Max is equal to min is equal to 10. That is, in general, we can write there is only one element, that is A of I. Then max is equal to A of I and mean is equal to A of I. Max is equal to A of I, also mean is equal to A of I. This is the first case. Second case, if there are only two elements, if there are only two elements, suppose there are two elements 10, 20, then there is only one comparison or only two comparisons, that is max is equal to 20 and mean is equal to 10. Here only, here no comparison. In first case there is no comparison, and in second there is only one comparison. And third case, that is it contains more than two elements, suppose 10, 20, 30. In this case max is equal to 30 and mean is equal to 10. Then there are how many comparisons? N minus 1. In general, I am writing if there are n number of elements, n number of elements, if n is greater than 2, if n is greater than 2, then number of comparisons n minus 1 comparisons. So we'll see apply divide and conquer algorithm with this. So the problem P is instance of that problem, and P which denote arbitrary instance, that is n number of elements, and the number of elements are A of I to A of j. The problem contains the parameters n number of elements and these are the actual elements. Here n also indicates size of array. Size of array, and this is array element. Okay, if n is equal to 1, if n is equal to 1, then A of j is, if n is equal to 1, then A of j is max and min. If n is equal to 2, then problem solved by making one comparison. And if n is greater than 2, then the problem P is divided into subproblems such as P1, P2, P3 up to Pk. We find the solution. Okay. Suppose we have divided into two parts. Did you get? इथपर्यंत समजलंय? Hello.
Yes, sir.
Suppose problem P is small, you can problem P is large. Divide the problem into sub parts. Our problem is n. The elements are A of R to A of J. So divide the problem into sub-problems. Suppose we have divided to two parts. So first part is, suppose this is your array 10, 20, 30, 40, 50, 60. Okay. So the 6 elements, that is n is equal to 3, and we divide A1 and A2. So first 3 here, 10, 20, 30, last 3 here, 40, 50, 60. Is in this array P1 here, first n by 2, that is size of that problem. Then here first element, second element, up to 50 of this array, that is n by 2. Size is total n. So A of n by 2. Similarly, P2 is divided into subproblem. Size is also n by 2. Then here next element, here A of n minus n by 2. N minus n by 2, first element. Second, A of n by 2 plus 1. Third element, A of n by 2 plus 2 up to last element A of n. Okay, after dividing these two problems into sub-problems, you should find the max and mean. Then compare their max and mean, which is largest or which is smallest, display the corresponding number. Okay. So now we are going to see the algorithm. So first, name of algorithm, min max, and parameters are I, j, min, max, then in comments we declare array 1 to n, array element n, n number of elements starts from 1 and ends on n. It is global array or general array, and in this case 1 is less than equal to I, is less than equal to j, is less than equal to n. 1 is less than equal to I, is less than equal to j, is less than equal to n. Then if there are three cases, first n is equal to 1, then second n is equal to 2, and third n is greater than 2. First we will consider n is equal to 1. If there is only one element, then I is equal to j. I is equal to j. If this is a true, then min is equal to max is equal to a of I. Because p is small, problem is small. And if this condition becomes false, then else, then we'll consider next condition, n is greater than 2, that is else if I is equal to j minus 1. I is equal to j minus 1, then here we are considering second condition, n is equal to 2 elements. See, array, there are only 2 elements, 10 and suppose 20. This is I, this is j. That is, this is 0th element, this is first element. So here in this case, I is equal to 0, I is equal to 1, and our condition is I is equal to j minus 1 minus 1. If this condition is true, then only one comparison of I is less than a of j. A of I is less than a of j, then max is equal to a of j and min is equal to a of I. ओके, इथपर्यंत समजलंय तुम्हाला? there are only two elements, that is I equal to j minus 1. This condition is true, but this condition is false. This condition is false. Then go to the else max is equal to a of I and mean is equal to a of j. Then this bracket complete. Then else this bracket complete. Now we are going to see next third condition. If n is greater than 2, then else that is p is not small. Divide the p into subparts. Divide p into subproblems. That is find mid. So mid is equal to floor I plus j divided by 2. I plus j divided by 2. And then go to here, solve the subproblems. Solve subproblem. That is, we are calling same algorithm, min max, with the parameter I. Here the array is divided with mid. So instead of j, here mid, then min, then max, then another second time we have called for solving problem second, min max. This is here parameters are instead of I, mid plus 1, j, then mean, then max. The problem, this is suppose this is your problem P. So it starts with I, ends on j. So it is divided into two parts with mid. This is problem P1. This is problem P2. So problem P1, while solving this for problem P1, this for problem P2. So Here I as it is, instead of J, we are writing here mid, end on mid, and min max as it is. And for problem P2, here I starts from mid plus 1. That's why here written mid plus 1, J min max we have written as it is. Okay, then after the solution, we combine the result, that is combine the solution. Solution if max, here instead of max, here we are writing max dash and min dash. So max is less than max dash, then max is equal to max dash, and if min is greater than min dash, then min is equal to min dash, and then end of the algorithm and complete the bracket. This is the algorithm for finding min and max with recursive algorithm. See this algorithm carefully. If you have doubt, please ask. We'll take pause of 2-3 minutes. Is there any query in this algorithm? Any doubt?
No, sir.
Okay. Roll number 824. A40. A67.
Yes.
Did
Yes.
you get? Is there any doubt? B34.
Yes, sir.
Is there any doubt?
No, sir.
B52. Is there any doubt? Okay. Now we are going to see the example on this algorithm. Suppose you have given array A, elements are 22, 13, -5, -8, then 15, then 60, 17, 31, and 47. Then this is the index. Index starts from suppose 1, 2, 3, 4, 5, 6, 7, okay. So in this example, I is equal to 1. Index number I is equal to 1 and j is equal to 9. Okay, and we should have to find max and min of this array. So we are applying the algorithm. First find mid. Mid of this, mid is equal to I plus j divided by 2, that is 1 plus 9 divided by 2. So 10 divided by 2, mid is equal to 5. So this is the problem P, which is divided with this mid. So there are two parts. First part, this is P1. This is part P2. Okay. So we write the problem P as I, j, max, and min. Okay, I is 1, index number, j is equal to 9. Maximum number of this whole problem P is 60 and minimum number is -8. Okay, so we have divided into two sub problems with mid. So this is whole problem P into two divided sub problems P1 and P2. This is problem P1 and this is problem P2. So divided into two parts. So here I as it is 1, J becomes 5 because J is equal to here last element for problem P1 1 5. Then greatest element from this problem P1 is 22. Smallest element from this problem P1 is -8. Similarly, in case of problem 2, I is equal to mid plus 1, that is here 6, J is equal to 9, then greatest element, that is max 60 and mean 17. Okay, this is a problem P1 and P2. Again, we divide into sub problems. Again, find the mid of these. For problem P1, 1 plus 5 divided by 2, that is 3. This is the mid for this problem P1. It is divided into two parts, P11 and P12. Similarly, we find mid for problem P2, 6 plus 9 divided by 2. The 6 plus 9 divided by 2, that is 15 divided by 2, that is 7. And 7 is the mid. So this problem is divided into two parts, P21 and P22. So again, we can write here for P11 and for P12. So for P11, I is equal to 1, J is equal to 3, and max is equal to 22, and mean is equal to -5. Similarly, for P12, I is equal to 4, J is equal to 5, max is equal to 15, and mean is equal to -8. Again, for P21, we can write I is equal to 6, J is equal to 7, then max is equal to 60, mean is equal to 17. Similarly, for P22, we can write I is equal to 8, J is equal to 9, max is equal to 47, and mean is equal to 31. Again, there are three numbers more than 2. There are three numbers in P11. Again, we find mid of these, and mid of these is here 2. Then again, here we divide into two parts. So I is equal to 1, J is equal to 2. -5. Max is equal to -5, mean is equal to -5. So the given array is divided into sub problems. with n is equal to 1, n is equal to 2. Okay, we'll see the problem once again in next lecture. We'll stop. If you have any query, please ask, otherwise we will stop.